Hello everyone, I'm Sumita from SNS College of Technology Department of Mathematics. Here in this lecture video series, we are going to see statistical data representation. In that, we are going to see histograms in this topic. So first, let us see what is histogram. So the empathize part. A histogram is a special type of bar graph that displays the frequency distribution of numerical data, unlike regular bars charts that show categories. So histograms group continuous data into ranges like bins, intervals, etc. So we almost have the values of the clusters, and we know how can we spread it out and where they are unusual patterns or outliers. So let us see the outline or anatomy of the histogram. So here in the x-axis, we will plot the intervals. Next, in the y-axis, we plot the given interval. Like for example, if we have a age in and time interval, then we will plot ages like 10, 20, 30 intervals in the x-axis and age of the boys or girls like 10, 20, and we'll map across. Next, bars. So each bar represents one interval and the height shows frequency and bar touches each other since data is continuous. So here usually comparing to the bar graphs, in the bar graph we show in spaces between two bar graphs, whereas in the histogram both are connected. Next, building your first histogram. The first one is to collect our data. So first we have to collect the data and we have to arrange that in ascending order or in the descending order. Then we have to determine the range and base. That is, we have to group the data as per interval. For example, if we have in 0 to 5, 10, 15, 20, then we can combine it as 0 to 5, 5 to 10, 10 to 20, 20 to 30 like that. Or otherwise, we have in large numbers like 50, 20, 30, 40 and all, we can combine it to 0 to 50, 50 to 100 like that intervals. Next is count frequencies. So we have to count the number of frequencies in that range of interval. For example, if we have 5 data in between 0 to 50 interval, we can count it as 5 frequencies. Similarly, we have to do for all the intervals. Next is we have to draw the graph. So create the bar with height matching the frequencies. For example, if we have 5 frequencies in the interval 0 to 50, then we have to draw 5 in the y-axis. Next, we have to make sure that the diagrams are very proper. Next is common histogram shapes and what they tell us. The first one is it is a normal distribution. So, as we know from the normal distribution, it's a bell-shaped curve with most data clustered around the center. So, data will be more along the center. So, common in natures like height, test scores, and measurement errors. Next is right skew. The dial extend to the right, often seen with income, data, or response times where a few extreme height values pull the distribution. Next is uniform distribution. So all the bars roughly the same height indicates data is spread evenly across all the values like rolling a fair die many times. Next is let us see one example. So this histogram shows basketball scores from 30 games. So most games 12 has scored between 21 to 30 points and suggesting this team typically performs in that range. A few games with very low, that is 0 to 10, or very high, 41 to 50 score represents unusual performance that coaches might want to analyze further. So here the data is given in the question or plotted in the graph like 0 to 10 ranges in the first, which is very low. Next, 41 to 50, which is a high one, which is in the last. Next, 21 to 30 range are totally 12, so it is plotted to the maximum. Next, the 11 to 20 and 31 to 40 intervals are plotted similarly. Next is design thinking application improving school lunch. So let us see one design thinking based example. So the first stage is in empathize. So in empathize, we find what is the need. So here the students are surveyed for their lunch preferences and satisfaction ratings to create a histogram to understand current satisfaction level. So the next one is to define. So here we are using this histogram analysis to identify the most common complaints and preferences. What pattern emerge from the data. Next is to ideate. The brainstorm solution based on histogram insights. If more students rate PISA highly, perhaps offer it more frequently. So the ideal part is what the students are needing in the most will be preferable. Next, test and iterate. So they implement changes and create new histograms to measure improvement. Let data guide your decisions. Next is the real world applications of histograms. So first let us see education. So in education, teachers use histograms to analyze test scores, identify learning gaps, and adjust instruction methods accordingly. So next in economics. So in economics, it is used to identify the income distribution, and we can use it for profit, loss, and some more trend analysis and all. We can use this histograms. Next, in healthcare, medical professionals track patients' vitals, medication effectiveness, and disease patterns using these histograms. Next, quality control. So, in manufacturing, to find the quality of the product, defect rates, and the product rates, we can use this histograms. Next, in weather analysis, meteorologists examine temperature ranges, rainfall patterns, and climate data to make accurate forecasts using this histograms. Next is here is the small summary of what we have seen in the video. So histogram is one of the statistical data representation method which falls under graphical representation. So first we have seen the definition and the purpose of the histogram. So it is used to um, visualize the data. Next, the anatomy. So what we plot in x-axis, what we plot in y-axis, and usually the histograms are bars, which we have seen in the anatomy. Next, building a histogram, we have seen the steps like to identify things and plot as such. Next, the common shapes and interpretation. So there are mostly normal distribution, right skewed, and uniform distributions. Next are the real world applications. We have seen um, in medicine, education, economics, and so on. Next, let us see the related concepts and uh, quizzes. So here, this is one of the curiosity challenge in which a mystery of Benford's law. Here's something amazing, that is, in many real-world datasets, numbers beginning with 1 appear about 30% of the time, while numbers beginning with 99 appear only 4.6% of the time. Phenomenon was called Benford law, applies to everything from stock prices to population data to the length of rivers. So it's so reliable that it's used to detect rainfall fraud.